All right, on to the next, or really the first type of reaction that I want you to do. Because what we just did in the previous stuff was we learned how to balance reactions. Now what's going to happen is I'm going to give you the stuff, the reactants on this side of the reaction, but you're going to have to write the products that happen to be on the other side. And at first I know that's going to sound like, oh my gosh, how in the world can I do that? But that's what I'm going to do is I'm going to teach you how to do it. There are 5 different reactions that we're going to learn. All right. Today we're going to learn 2 of them ultimately. But the first one happens to be combination. All right. Combination or synthesis. I'll write that up there so we know that that's what we're talking about. Combination or synthesis reaction. For this one, exactly what the word says, combination, we're going to combine something. We're going to combine 2 elements. And synthesis means to make. So we're going to make something out of 2 elements that are sitting there. So let's utilize our first one. We're going to use the idea, we're going to take H2 plus O2. And then it's going to form something. I know you're going to go, well, we did this one and the other one. Yep, I know. But now I want to see how they got the products that were formed. All right. So what you have to do in this one is when you come across from the reactant side over to the product side, one of the first rules I always like to tell everybody is don't bring any numbers when we're only talking about single elements. All right. I will come back on that and say the only time we're going to bring elements or numbers is when we use something that comes from that polyatomic ion table that you should still have, this one. All right. When you bring one of those, then you're going to bring numbers, but we'll worry about that a little bit later. So right now, don't bring any numbers across. So all we're going to bring across is the H and the O. And we're going to put those 2 together. Okay. So now that I have the H and the O together, then what I have to do is now I got to use my ionic charges in order to come up with what the formula is. So I have to go to the periodic table and look up and go, well, hydrogen's in the very first row, so he has a +1 charge, right? And oxygen is way over on the right-hand side, he's got a -2, which let's look at that. Find my periodic table. Where'd it go? There it is, just down underneath everything. This is a little refresher. Remember that everything that's in this first row has a +1. These guys all have a +2. The ones in the middle, they have a +2, unless they have a Roman numeral, which overrides that, and that Roman numeral is the positive charge. These ones, +3. These guys are plus or -4. These guys are -3, -2, -1, 0. So hydrogen, he's in this very first row, he was a +1. We got oxygen right here, that's 0, -1, -2, so he had a -2. So that's how we get those charges. So now those guys don't cancel each other, so I got to crisscross them. So I'm going to take the 1, put it over here, leave it blank, take the 2, put it down there, and do that. And oh, look at that, I end up with H2O as my formula. So that's how I end up with the formula. Then what I have to do is now I have to balance it. So just like we did in the other ones, we're going to go, well, there's 2 H's plus there's 2 O's. That's going to be equal to 2 H's and an O. Well, now it goes back and go, I got 2 H's, that's even. 2 O's, 1 O, that's not. So I need another one of this guy. Now I got 2 O's, 2 O's. Now I messed up my H's, so I need another one here. Now I got 4 H's, 4 H's, 2 O's, 2 O's, all done. Now I'll go back and do my numbers. 1, 2, 2 of that guy, 1 of this guy, and 2 of this guy, so I'll put a 2 there. All right, and that's my answer right there as the combination reaction for H2 plus O2. All right, let's do another example of this, another combination or synthesis reaction. So we're going to go K plus Cl2. Put those together. So again, when we bring them across to the other side, or here on the other side of the arrow, we're only going to bring the elements. So we're going to bring K, and oops, don't put a plus in there. Take the K and the Cl and put them together. Notice there's no plus in between. We're not adding them together anymore. Now they are together. Once I've done that, now I do their ionic charges. K, he's in the very first row, so he's a +1. Cl, he's in the very last row, so he's a -1. So what do those 2 charges do? They cancel each other. So we're just going to leave it as KCl, because it's really 1 to 1, which means we leave it blank. All right, now what we got to do is now we're going to do our circles. So go back and go, well, I got 1K plus 2 Cl's. That's equal to a K and 1 Cl. So my K is 1, 1. Those are even. Cl's 1, 2, 1. So I need another one of this guy. I got 2 CLs, and I need another K. And now is everything even? Yep, everything's done. 1, 2 Ks, 1, 2 Ks, 2 CLs, 2 CLs. Now I do my numbers, 1, 2, 2 of that guy, 1, leave it blank, 1, 2, 2 of that guy. There's my reaction that two molecules of potassium will combine with 1 Cl or chlorine, and that's going to form 2 molecules of KCl. That's what that equation says. All right. Okay, now we're going to go on to the other type. Let me erase all this. So that was combination or synthesis, where you're putting them together. Now what we're going to do is now we're going to do decomposition. What does decomposition means? Means we're going to tear it apart. So now we're going to do the reverse. We're going to take something that's already put together and we're going to break it apart. So let's start with an easy one. Let's go with water. So now we're going to do the reverse reaction. I'm going to take water and I'm going to run electricity through it. Don't do that. It's very dangerous. It'll kill you. But if you did do this in a controlled environment, it will actually take the hydrogen and oxygen and separate them. Right? So what's going to happen when I come across the other side of the arrow, I'm going to take the 2 elements and I'm going to go put hydrogen and we're going to separate that with a plus sign and go oxygen. So I end up with hydrogen plus oxygen. Now the next thing in doing this is now we have to look at these. We don't have to do the crisscross thing because they're not together. But there is something that we do have to do, and that is we have to look to see if they are what are called diatomic elements. Right? And this is in your notes. The word diatomic. If you look at this, di means how many? 2. And then atomic means atoms. So there's certain atoms or elements on the periodic table that have to be 2'd if they're all by themselves. And the ironic piece to this is there are 7 of them. Right? And the 7 that there are actually makes a number 7 on the periodic table. And what they are is they are nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Look at it, there's the number 7 on the periodic table. Now, if you're looking at me going, Mr. Pape, that's not 7, that's 6, because you have to remember that there's one other one. This one you'll just have to remember is hydrogen. And hydrogen also is diatomic. What does it mean to be diatomic? Is when they are all by themselves, they won't be just H. It's going to be H2, it's going to be N2, it's going to be O2, F2, Cl2, Br2, and I2. Now again, that's only when they're by themselves. The way in which I always like to describe this is they are very, very lonely. When they're by themselves, like this guy, he's all alone. He's like, oh my gosh, I don't want to be all by myself. So he joins up with another hydrogen and goes, there, I feel better now, I got a buddy. So he's got 2 H's. And the O over here goes, oh my gosh, I'm all by myself. So you go, oh, there we go, now I feel better. I'm with somebody else just like me, right? Now over here you might go, that oxygen is not diatomic. But is he alone? No, because he's joined up with the H's. So he's like, ooh, man, I got a buddy. All right, I got 2 buddies hanging out with me. I'm good. They don't like being all alone. And remember, it's those 7 elements: nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. That's the 7 that are on there. And unfortunately, yes, you're going to have to memorize those and know that when they're by themselves, they have to be 2'd. They have to be diatomic. Okay? All right, then what we'd have to do is now we got to balance this thing. I'll do it really quick because I hope you're getting this one because we've done it a bunch of times now. But there's my original bubbles. So I got 2 H's, 2 H's, 1 O, 2 O's. Oh, needs more of this guy again. And then that means I need some more of this. Oh, look at that. It's the same thing we had before. I got 2 of this guy, 2 of that guy, and 1 O2. And that's my balanced equation for that one. All right. Now let's try another one. That's decomposition. So we're doing BeO. And we're going to tear that thing apart, decompose it. So again, to decompose it, I take the 2 elements, separate them. So I'm going to go Be plus O. Then my second step I got to do is I got to look at it and go, is he one of the diatomic dudes, like I like to describe? Is he one of those 7 that's on the periodic table? So we got nitrogen, oxygen, fluorine, chlorine, bromine, iodine, hydrogen. Nope, he's not. So he's not diatomic, he's just 1 all by himself. Is oxygen diatomic? Yes, he is. So we got to put a 2 by him. All right, now that I got my diatomics done, now it's time to balance it. So I got 1 Be and an O. That's got to be equal to a Be plus 2 O's. So my BE's 1, 1. O's 1, 2. So I need some more of this guy. I guess my O's even, 2 and 2, but now my BE's are messed up, so I need another one of that guy. So I got 1, 2, 1, 2, 1, 2, 1, 2. Everything's even. So now I put my numbers in. I got 2, 1, 2 of that, 1, 2 of this guy, and 1 circle of O2. And that's my balanced equation for that one. I think that was all my examples I have. Yep, that's everything. So now we're going to move on and do some examples of these as the work and next up and coming assignment. So we'll see you later on. Have a great day.